Okay, we're given the volume of a pyramid is equal to 1/3 of the area of the base times the perpendicular height. And then we are told VABCD is a rectangular based pyramid, so it's just given us the vertices, so this is all the shape, is a vertically based pyramid, a rectangular based pyramid with a volume of 336. X is the centre, and then we've got the horizontal base there. So it's just giving us all the key information about that shape. So we don't need to make any assumptions. We are told that this is the centre, so that is our height. So this is our perpendicular height there, which is talked about in the question. And we're asked to work out the angle between VB at the base. So the line VB is here, and you're asked what angle that makes with the base. So this bit here is that angle there. So straight away I'm thinking, well, you wouldn't have told me all that information above if you're just expecting to do that straight away. So this is our last end goal. We'll come back to that right at the end. I always think it's best to work out everything we know. It's worth 6 marks, so you know there's quite a bit going on. So they wouldn't have told us the first bit about the volume if we weren't going to need to use it. So let's work with that to start with. So the volume is 1/3 of the area of the base. So the area of the base in this question, so there's our base, it's 8 by 14. So the area of the base is 14 times 8 because it is just a rectangular base. So 14 times 8. So 14 times 8, grab your calculators, is 112. So it's 1/3 of 112, so that's our area of our base, times our perpendicular height. Well, we don't know what that is, so I'm just going to call it H, just so we got one letter, so I'll change it on there. So we've got H times our height. So I'm using that formula that was given in the question. I've subbed everything I know, I've worked out that, but that doesn't look good because I'm thinking, well, I don't know H, but what I've missed off is, well, I know that's equal to the volume. So it's equal to the volume that was given of 336. So if I can work out this bit, I can then work backwards and work out the height. So if I do 1/3 on the calculator, so again, type it all in, 1/3 of 112. That's going to give us 37.3 recurring. Now I'm not going to take that off the calculator anyway, but I'm just going to jot it down just for make sure that I'm showing the examiner what I'm doing. 37.3 times the height should make 336. So to get the height, to work the height out, that's currently being multiplied by that, so the inverse is to divide by that 37.3 recurring, divide by 37.3 recurring. So the way I'll do that to make it easy is just leave it on the calculator and do 336 divided by the last answer on the calculator. But if you don't feel happy with that, which gives us 9, if you don't feel happy with that method, then you've got the option of obviously just typing it in so you can see it. But we do really need to give the calculator some credit. It is really clever at it. But there's our button if you're not happy with it. So 37.3, we would type 37 point. Hit that button, shift on that one, that gives us the recurring, but have confidence in the calculator, it does give you the right answer. So the height is 9. So our H on here is now 9, so I'm going to replace that with a 9 so I can come back to it. Right, so my aim is to work out this one, so have I got enough information about it now? Now because this is right angled, because it's perpendicular, it meets at 90 degrees, it creates a lot of right angled triangles. So this triangle VXB, although it doesn't look 90 degrees, this is obviously because of the visualization in the 3D aspect of it. When you actually take that triangle and turn it, if you imagine placing that, it would look like this. So if we actually took it from there and actually turned it and looked at it in a 2D perspective, this is what that triangle would look like. It would be 9 on the height. We don't know that point there, so we don't know. So let's just put that's Y, that's X, that's B. We don't know that one, and we don't know that one. but we want to know that one. Now that's not a lot of information to work with. It would be nice if we knew one of these two, so that we could then use our trick. So if we can work out one of these two, doesn't matter which one we can work out, then we can use that to work out this angle here. So there's different methods we can use for that. We can try and think, well, this angle here, sorry, not angle, this position here is, because it's central and it's that perpendicular, is going to be half of that there. So whatever this length is here, this is going to be meeting halfway, or vice versa this way, it's going to cut it exactly in half. So if we can work out what that length is, we can then know that one. So by doing that, because obviously it's rectangle, so there's also 90 degrees everywhere, I can use a triangle there, which is 14, 8, and then the one I'm looking for. So I've got 14, 8. Oh, I'm slightly turned. Let me twist that back to you guys. Sorry, there we go. I'm just working on that triangle here, which is no different to working on that triangle there. But all it's going to do is help us to work out... Hang on, do I need that? Am I making this up? Yeah, it's going to help us because we've got that triangle there. So either way, we've got loads of triangles, 4 triangles on there. If I can work out one of the diagonals, it's half for that, so I can work out that point there, which I wanted x to be. There was a method for it. So either way we do it, we're looking at here Pythagoras' theorem. So a squared plus b squared equals c squared, where a and b are our two shortest sides, so it doesn't really matter which way around that goes, but that would be our c. So 14 squared plus 8 squared gives us 260, and then the square root of 260 would give us our c squared. So this was 260 equals c squared, therefore our c is root 260, which is better known on the calculator as 2 root 65. I'll leave it as 2 root 65 for now. So what I know is that this length from there to there is obviously the same as that one there, because it doesn't matter which way around to do that. That would, if that's 14, that's all I've done, but I've just done it the opposite orientation. 14 there, and that's 8 there. So it's still the same triangle. What I now know is that the distance from D to B is the whole way across there is 2 root 65. And now because this is going to be half of it, I left it on the calculator. Well, if you halve 2, you're going to get 2 lots of root 65, but if you want to do it on your calculator, divide that by 2. It'll just leave you with root 65, and that's what gives us there. So from there to there is root 65, or if you prefer it as a decimal, S to D 8.0622. Root 65, which is 8.0622. So on the diagram now I know that length there is that. So I can now use this information in my right angle triangle then, because I've got 2 pieces of information that I can work with. So because I wanted to use that, I can now think about what can I use to work out with the right angle triangle. So let's take it down here so I've got some space. I've just worked out, am I on cam? Yeah, just worked out that that's root 65, that's 9, and that was what I was looking for in the question. And it is a right angle triangle. So if I label this, because it's a right angle triangle, I can use trig. It's the angle that I'm looking for. The 9 is the opposite one. Opposite the right angle is the hypotenuse, and the root 65 part is the adjacent one that's left alone. So we're looking for the ratio with O and A in. Write your triangles out. The horny caterpillar only has sex on a Tuesday. And we are looking for the one with the O and the A in. The only one with the O and the A in. I mean, you could go and be like, yeah, this one's got an O in and this one's got an A in, but the only one with the O and the A in is that one there. So at a quick glance we can see it has to be that one there, the one with the O and the A. So we're looking at tan. I don't know why I wrote tan, but hey ho, we're looking at that triangle. So in order to work out the angle, we cover up the tan. So we're looking at, we've got the O and the A, so we can't cover them. We're looking for the angle, so it's tan is opposite over adjacent. So the tan of the angle is opposite over the adjacent. So tan of x equals opposite, which is 9 over adjacent, which I'm going to keep as root 65 because that keeps the accuracy in the question. But if you prefer 8.062, you can use that. Now, if you know when you're looking for an angle, we use tan to the minus 1. You can write that straight in. So we can go tan to the minus 1 of 9 over root 65. If you're not too sure at that method, what you would have realised is if you do 9 over root 65, you get a ridiculous decimal, and you're like, that can't be the angle, and you end up having to press shift tan to the minus 1 of your answer. And that will give us 7.88. Whereas if you do it, because you know you're looking for an angle, you go straight into tan to the minus 1, which is just the inverse for the angle, and then you do your 9 divided by your root 65, your root 65, and then, let's delete that, and then close that. It will give it you straight away. Hang on, I feel like I've got two different answers for that. Tan 9 over root 65 gives me 48. Let me just jot that down a sec. Equals 48.14. 9 divided by root 65. Oh, is 1.1. So something must have gone wrong on my last calculation. So if you did 9 over root 65, you'd have got that. And then shift tan to the minus 1 of your answer. You get 48. So both ways you do it, you get the right answer, 48.14. And that would be it. That would be that angle there, VB, is 48.14. Okay, so that is one of the ways you can do it. Is there another way? Let's have a little think. The only other thing that you could have done is worked out that length there. And obviously you could have done that, which is fine, but you'd be doing unnecessary work because if you've got this one, you've got enough information. But obviously if you wanted to work out this length here, you would have got marks for it. Because that length, if we think about Pythagoras, if that's root 65 there, we could work out that one by doing 9 squared plus root 65 squared. So another mark if you did this, so 9 squared plus the root of 65 squared equals 146. So we've got a squared plus b squared is c squared. We'd get a and the b is 146 equals c squared. So c would be root 146. Which is 12 point something. 12.1, let's call it. So obviously if you did do that one, you could have worked out that, which would have given you the flexibility to use any of those triangles, because if you know that that's root 146, you would have the hypotenuse, which would just give you the freedom to use either cos, sine or tan. But the easiest way without extra work is just to go straight in and use the tan.